Welcome to this presentation of a case study involving a highly corrosion resistant nickel based alloy called Hastelloy C276 in a plate type heat exchanger. This heat exchanger is used to cool sulfuric acid which is produced in zinc industry as a byproduct. This requires cooling by cooling water. The plate type heat exchanger provides cooling water. The plate type heat exchanger consists of plates in which holes are drilled to form a pipeline in which cross pipeline concentrated sulfuric acid which is hot, which flows on one side and comes out as a cooled acid. And the cooling is done by supplying cooling water on other side in the opposite direction, and which collects the heat from the acid and comes out little bit of warm water on the outside or other side. So in this process the acid is cooled. The hastelloy being very expensive material, it is used as thin plates. In this process, uh, after a few months of operation, leaks have developed, and you can see the leaky portion. The one on the left side it shows on the acid side, and you can see general no acid, no corrosion zone. Whereas here on this area there is a patch of corrosion area, and in which pinholes are formed. You can see the pinholes there. On the same side, uh, on the same portion, we are looking at the water side on the right hand slide. And this right hand slide shows the pinholes, and then surrounded by a certain type of features which is created by the water. And once the acid leaks, the that area becomes a dilute acid, and dilute acid is more corrosive than concentrated acid. In addition to this, you can see series of white circles which will be shown in the next slide. You can see that acid side, you can see the three pinholes very clearly, and surrounded by area where dilute acid has corroded the hastelloy. Whereas here you can see the same three pinholes on the water side. In addition to the pinholes, you can see a circular pattern, a uniform circular pattern which was not there earlier. And these circular patterns are called bacterial colonies. Very fine bacteria which is always present in cooling water, leading to this kind of attack. This is called bacterial corrosion. And so the water has not been apparently not treated against bacteria attack. Hence this attack has formed due to dilute acid side, and dilution has occurred due to water. Uh, so the diagnosis is bacterial colonies on the cooling water side have formed, and bacterial colonies act as corrosion sites where local corrosion take place, because bacteria always gives rise to very specific acidic solutions, localized solutions which lead to pitting corrosion. So the microscopic bacteria thrive in these colonies, generating highly acidic secretions. Secretions is the word used for bacterial outlets. And since the bacteria strongly cling to the metal surface, these acidic solutions remain stagnant and initiate and propagate pitting corrosion, very localized pitting corrosion of the underlying metal, fastly leading to pinhole leaks. This is the diagnosis. The recommendation is proper chlorination with specially studied and formulated biocide treatment. Any cooling water systems require chlorination. Unfortunately, it is not being done in this case. And now, after this case study, as a result of this case study, the formulation biocide must be proper biocide has been used so that it will kill the bacteria and stop this problem. Thank you very much. Thank you.